Welcome to True Projects. In this video, we are going to explain about a project titled Student Feedback Management System. In the realm of education, student feedback holds immense significance as it shapes and improves the teaching methodology, course content, and overall learning experience. Embracing innovation, our transformative endeavor aims to develop and comprehend an efficient system, streamlining the collection, analysis, and management of the student feedback. Through the data-driven insight, educational institutions gain the ability to identify the area of improvement and implement the necessary changes. The system fosters a more engaging and student-centric learning environment, enhancing the overall educational quality. Transparent communication and a culture of accountability are fostered, bridging the gap between the student and educators by actively incorporating the student feedback. Our project emphasizes the holistic development of the student by actively considering their opinion and experience. By valuing the student feedback, we foster a collaborative learning ecosystem where the educators continuously strive to provide the better educational experience. And the objective of this project is to accomplish and encompassing the precise of the student feedback by employing the system with machine learning algorithms like Neo-based KNN decision tree to analyze and process the student feedback data. By harnessing the power of these algorithms, we strive to create a robust sentiment analysis model capable of categorizing the student feedback into the positive or negative sentiments. The primary goal of this project is to equip the educational institution with the valuable insight into the student opinion and experience and the satisfaction level. This will enable the institution to identify the area and improvement to take proactive measure to enhance the overall learning environment for the students. Additionally, our project seeks to streamline the feedback collection process, ensuring that student voices are heard and fostering a culture of continuous improvement in the educational institution. And the implementation of this analysis system will not only enhance the educational institution reputation, but also improve the communication channel between the student and the educator, leading to the more productive and harmonious learning environment. These are the basic requirements that are needed to build this project. The software requirements are Python IDEL with version of 3.7 or Anaconda with version of 3.7 or Jupyter. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. Here, in this step, the libraries of Panda, NumPy, Scala. These libraries provide the necessary tools for data manipulation, analysis, and model building. And the second one is importing the dataset. We gather the dataset containing the student feedback on various aspects of the academic experience, such as teaching, course content, examinations, lab work, library facilities. Each aspect is associated with a sentiment score that represents the level of positivity or negativity expressed by the student. And the third one is test pre-processing. Here, we perform the pre-processing tasks such as tokenization, lower casing, removing the stop word and the punctuation. The test pre-processing ensures that the input data is in suitable format for the sentiment analysis. And the fourth one is sentiment intensity analyzer. In this, we incorporate a sentiment intensity analyzer to quantitatively measure the sentiment expressed in the student feedback. Here, the WADA, the Valence Aware Dictionary, and the Sentiment Reasoner is lexicon-based tool used to estimate the sentiment score from the test data. We leverage the WADA to obtain the sentiment score for our student feedback data set, which aid in building the sentiment analysis model. And the next step is building the model. Here, the first one is Neo-based. Neo-based is an excellent choice for the sentiment analysis as a probabilistic classifier. Neo-based work well with the test classification task, including the sentiment analysis of the student feedback. It relies on the Bayes theorem, assuming that features are conditionally independent given by the class label. Despite its name assumption, neo-Bayes performs surprisingly well in many real-world scenarios. In our contest, it efficiently analyzes the sentiment expressed in the student feedback. And the second one is KNN. It stands for K nearest neighbor. It's a powerful algorithm for student feedback by classifying the data based on the majority class of its K nearest neighbor. It effectively captures the similarity between the test sample. In this contest, it compares each feedback aspect with the most similar feedback sample to determine the sentiment score. Its initiative approach makes it easy to implement and understand. And the third one is decision tree. Here, the model proves two valuable assets. Here, it uses a tree-like structure to make the decision based on the series of rules derived from the training data. For sentiment analysis, decision tree effectively captures the nonlinear relationship between the feature and the student feedback. By navigating through the tree, the model determines the sentiment score for the different aspects of the feedback where the decision tree are interpretable, allowing us to gain the insight into the logic behind the sentiment classification. Their ability to handle the non-linearity is essential for capturing the complex and sentiments expressed in the student feedback, making them suitable for our training the sentiment analysis task. And the next step is training the model. With the model built, we train them using the pre-processed student feedback dataset. The model learns from the input data to understand the relationship between the different aspects of the feedback. And the next step is user gives the input. To enable the user interaction, we create a user interface using the class framework. Here we need to give and message whether the framework will take it and will predict it. The next step is the given input is pre-processed for prediction. The user provided feedback is pre-processed user the same technique applied to the original dataset. And the next step is trained model is used for prediction. The pre-processed input is fed into the trained model for the sentiment analysis. Each model processes the feedback and assigns the sentiment score to the different aspect. And the last one is final outcome is displayed. The final outcome is displayed to the user through the interface showing the score for each aspect of the feedback. This provides the valuable insight for the educational institution to identify the strengths and the areas of improvement in the offering, fostering a more student-centric and fulfilling learning environment. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder. And this is the code folder containing of various files within it. The static folder containing of CSS, font, images, JavaScript folder within it, and the template folder containing of HTML documents within it that are home, index, notebook, result sign-in and sign-up pages within it. And the final data set is an CSV file containing of the information within it used for the data set for the pre-processing. And the model is an pickle file which contains the information of the algorithm and loaded into the project code during the runtime to utilize the trainer model for the various tasks such as making the prediction on the new data, performing the specific operation. And the notebook is an IP by NB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And app is an PY file which contains the information related to the front-end logic. It includes the code written in Python that handle the server-side operation, such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the signup.db is a file appear to be the database file used to store the user information. And to execute the project, we build a class framework as frontend. For that, we need to copy this address of the code folder and then open the Anaconda prompt. First, we need to change the location of the disk to F because our code folder is present in fdisk. Then write a command cd space and paste this code folder path. By this, it will change the directory to the code folder's path. And then write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for the syntax errors and the logical issues. After running this app.py file, it will execute the plus framework by building and local add link like this. We need to copy this local link and paste it on any of the web browser, and I prefer to use the Google Chrome. And pasting this and click on enter button, it redirected to the page as of like this. And it contains of sign in and sign up buttons. Then click on sign up button. Here we redirected to the sign up page. We need to fill this necessary details that are need to be filled to create an account, but my account is already generated, that's why I'm using the sign in button. Here it redirected to the sign in page containing of username and password, and fill the details of username as admin and password as of admin, and then click on login button. Here it will redirect it to the index page containing of an message box where we need to enter the feedback, and I'm entering the feedback as extracurricular activities also help the student to divert their mind from their study for some time. University plays an important role in this task. And then click on submit button. Here it redirected to the result page and use its the feedback is of positive. And then here click on the try again button. We redirected back to the index page and enter the another message like of no comments, because when you participate you get reappear or backlog, and no time is given for exam preparation. And then click on the submit button. Here it redirected to the index page and shows as of negative feedback. In this way we can view the feedback of the student by using various algorithms. And in conclusion, our project successfully achieved its objective of developing a robust sentiment analysis system using the naive-based KNN decision trees algorithms. By harnessing the power of machine learning, we created an efficient platform that allows the education institutions to collect, analyze, and process the student feedback effectively. The sentiment analysis model provides the valuable insight into the student opinion and experience, enabling the institution to make the data-driven decision to enhance the learning environment and address the area of improvement. The system's user-friendly interface fosters a culture of the open communication between the students and the educators, encouraging the continuous improvement in educational practice. Moving forward, this project impact is expected to lead to the more student-centric and fulfilling the learning experience, ensuring that educational institution can better meet the student needs and expectations, ultimately driving the academic success and the satisfaction for all the stakeholders involved.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.